I don't know about that.
I've seen Damon.
All right. Everybody got their butts sufficiently kicked yesterday?
Yeah.
Dude, that was so.
That was terrifying.
Yeah, can we get our test back?
Bro, I want to see how badly I failed.
You'll see it again when we take a post-test.
How do we know we got all that?
You'll know when you get the post-test. It's called the joy of anticipation.
That's like 6 months.
It won't be that long. All right, I think I got everybody's name memorized. It might take me just a second to make sure. So would you take a look at the warm-up right now? Go ahead and get answers for those 4 questions. Just to simplify, this will happen quite a bit. Today, the I can statement is, I can simplify expressions with integer exponents. So this is going to be a review of stuff that you've seen before. Seen it a couple times probably. Saw some in 8th grade. Saw some in 9th grade math, secondary 1. Give you a second to look at it. 1 through 4 on the warm-up. If you get done with 1 through 4, you can start copying the examples. When I started looking at this yesterday, we've revamped some of these notes. The properties are the same. The examples, you don't have them on yours. So if you just leave enough space that we can write an answer and everything, that'd be great. Okay, now that I know everybody's name, I might just call on you just cold, so be on your toes, or I might take a volunteer. So if you're copying down some of the examples in the table, that's fine. Go ahead and pause for a second. Be on your toes because I need an answer for warm-up number 1. Zach.
125.
It is 125. Can you tell us how you know it's 125?
So it would be 5 times by 5 times by 5.
Very good. 5 to the third means the exponent tells you how many times you use the base, so it's 5 or 3 5s. 5 times 5 is 25 times 5 is 125. By the way, stop and listen. One of the things people mess up in calculus is they don't remember the rules for exponents very well. So that's one reason why we're doing this. These are going to come up again and again in more complicated situations, so you want to make sure you've got them. Somebody raise their hand for number 2. Crew.
Yes.
What'd you get?
26.
You got 26. How'd you get 26?
I did like 2 times 2 times 2 times 2.
4 2s, so that makes us 16, and then we add the 10, right? Okay, why didn't you do the addition before the exponent?
Because it would be wrong.
Why would it be wrong?
Because math rules.
Math rules. Can somebody help them out? What math rule tells us we've got to do the exponent before addition? Samara? Okay, PEMDAS. Okay, the order of operations. We do parentheses, no parentheses. We don't have to simplify anything in parentheses. We do exponents. Take care of that exponent. We get a 16, then we do the addition. Somebody raise their hand for the next one, number 3. Dane?
41.
Dane got 41. Let's check and see if he's right. Now, if I understand what people are doing correctly, this right here, parentheses, you'd get a 7. We're going to square that, and then we're going to subtract the 8. 7 squared means 2 7s, so that would be 7 times 7 is 49. And then we're going to subtract the 8. We get 41. Everybody good with that? Okay. Volunteer for this one? D.
Yeah, 1.
You got 1. Okay. Tell me how you got 1. I'm not quite sure about that.
2 to the power of 2 equals 4.
2 squared is 4 plus 3 is, okay?
And then 7 over 7 equals 1.
Okay, so fraction bar is the exception to the order of operations. You'll notice that we're doing the division at the very end. We do all the stuff on the top. We simplify the top. We end up with a 7. On the bottom, we get a 7. Then the very last thing we do is the division. So a long fraction bar is a grouping symbol. It groups the top together, the bottom together. You get an answer for the top You get an answer for the bottom, then you carry out the division very last. That's the exception to the order of operations. Any questions? Okay. Now, I am hoping that everybody knows these examples. This is just a quick reminder. So this is called the product property of exponents. Product property of exponents. And again, we're going to assume all the bases are non-zero, okay? And really non-negative is what we really ought to assume there. So if we're multiplying them, then we add them together. So for this example, m to the second times m to the seventh, m to the ninth. T to the negative 1 times t to the fifth. We'll go over negative exponents again in just a second, okay? But this is going to be t to the fourth. Power property of exponents. Power to a power. This exponent applies to each one of those things here. So we apply the exponent to the x, and we apply the exponent to the n. So we get something that looks like this. Again, a numeric example, maybe the one that'll make a little bit more sense, is this is 3 squared and m squared. So we get 3m squared for a final answer there. Quotient property of exponents. Kind of makes sense. If we're multiplying and we add the exponents, then if we're dividing, we're going to subtract the exponents. We're going to subtract the bottom from the top, if you want to think of it that way. So this one's going to be p to the 6 minus 4. So that's going to end up being p to the second. If it's okay with you, everybody take a look up here. This is kind of a silly way to think of it, okay? Because on the next one, here's what we're going to end up with. We're going to end up with x to the 3 minus 10, which is going to be x to the negative 7. And we don't normally write things with negative exponents. So a better way, in my opinion, to think of this is to think of it this way. There are 6 p's on the top, there are 4 p's on the bottom, and 4 of these are going to cancel with 4 of those. So rather than always saying, I'm going to subtract the bottom exponent from the top one, just think of it this way. I'm going to subtract the smallest one from the biggest one. So I'm going to take this one and I'm going to say this is p to the 6 minus 4. That's p to the second. For this one, I'm going to take the big one and subtract the small one. So that's going to leave an x to the 7th on the bottom and a 1 on the top, just like that would have a 1 on the bottom. Okay? You can get to the answer quicker in a more usable format if we always take the smallest exponent and subtract it from the biggest exponent and leave it wherever there were more. 6 p's on the top, cancel with 4 p's on the bottom. 2 of them are left, they're on the top. 3 x's on the top, 10 x's on the bottom. 3 of them cancel, there's 7 left and they're left on the bottom. Everybody good with that? We okay there? All right. Next one, again, this is power to a power. So kind of another example like this. When we multiply, when we have a power raised to a power, I think I might have said that wrong up here. We're just applying this and kind of distributing it through. Okay, this is a power raised to a power. So we multiply those two together. So an example would be x squared to the third. This is going to be x to the sixth. So if you haven't seen this before, up above, would you write add, subtract, multiply, divide, and then would you write exp for exponents? Normal math and normal numbers work like this. If you're adding, you add them. If you're subtracting, you subtract them. If you're multiplying, you multiply them, and all good. If you're dealing with exponents, this is the way it works. If you're multiplying the exponentials and they have the same base, you take 2 steps back and you add the exponents. If you're dividing them and they have the same base, you take 2 steps backwards and you subtract them. If you've got a power raised to a power like the example that we just did right here, so let me highlight that one right here, then we take 2 steps backwards and we multiply them. Okay? So if this is an exponent of 3 raised to an exponent of 2 raised to an exponent of 3, we multiply those together and we get an exponent of 6. Okay, any questions there? Okay, x to the 0 is equal to 1. Any number to the 0 power is equal to 1. So here's one reason for that. If I use this rule up above, this would be x to the 3 minus 3. That would be x to the 0, so that would be a 1. And the reason it's a 1 is because we have the same thing on the top as we have on the bottom, and same thing divided by same thing is always going to give us a 1. So there's one reason. Okay, can anybody come up with another reason? Mason thinks he's got something. Mason, go for it.
So if the fundamental idea of exponents is that you're repeatedly multiplying starting at 1.
Very good.
So if you're multiplying 1 0 times, or well, yeah,
If you're
at
starting with 1
and you're multiplying by your base 0 times, then you're going to stay at 1.
Very good. So does everybody get what he's saying? What he's saying is if you have x raised to some number right here, you always start with 1 and then you multiply by x repeatedly. So exponents are repeated multiplication, and if we have x to the 0, well, there's nothing else we're multiplying. Great example. Okay, nice job. Okay, so we wouldn't have any x's. We just have a 1 on that side if we said we're not going to multiply by the base at all. Okay. This one right here, again, this is kind of an example of what we've got up here. We're just applying the exponent to the top and the bottom equally. So this is x to the m over y to the m. Apply it to the top and bottom. So this is going to be x to the m here, and I should have made that a number. In fact, let's do that. Okay, will you make that a 3? Okay, this will happen every once in a while. We've got notes that aren't quite right. Okay, so this is going to be x to the 3rd, and this is going to be 2 to the 3rd. And 2 to the 3rd is a small enough number. We probably ought to just take care of it. So this is x to the 3rd over 8. That's how we're going to write that. All good? Okay. A negative in the exponent means, we could sum it up with one word.
Fraction.
Fraction. I'm going to write this, reciprocal. It's a little bit more descriptive than just saying a fraction. It is going to work out to be kind of a fraction most of the time. When we say reciprocal, a negative in the exponent means we're going to go from top to bottom or bottom to top. So here's an example. If I've got x to the negative 4, the reciprocal would mean we'd put that same expression on the bottom. It's going to be 1 over x to the 4th. By the same token, if we've got m to the negative 1 on the bottom, we're going to take that and we're going to move it to the top. So this is going to be m to the 2nd on the top. So in short, you can change the sign of the exponent by moving it from top to bottom or bottom to top. Okay? Now, I'm going to build on what Mason said just a second ago. If you caught what he said, it was really smart. Okay? Exponents are basically repeated multiplication. So if I write something like this, x to the 4th, it means I multiply by x repeatedly 4 times. What does a negative mean? Fundamentally, when we say negative, what word does that mean? Negative means opposite. What's the opposite of repeatedly multiplying? Think about it for a second. What's the opposite of repeatedly multiplying? Dane? Repeatedly dividing. So we're going to divide by 4 x's. We're going to divide by x 4 times. And what's the easiest way to write x to the 4th in the denominator? 1 over x to the 4th. So there's another reason, another kind of rationale for that. Okay? And then this one right here, you could apply it equally to each one of these. Again, power to a power rule. X to the m to the negative 1, you'd multiply those together, get x to the negative m. Y to the n to the negative 1, apply the exponent, multiply those together, you get y to the negative n. What does the negative in the exponent mean? Reciprocal. So we flip this up here and this down there, and we get that answer. You want a shortcut? Especially if it's just one negative on the outside? What does negative in the exponent mean? Flip it over, reciprocal. So we get y squared here and x to the 3rd here, and you can change the sign of that to a positive. In this particular case, does it matter if we have an exponent of 1? It doesn't. So we could just get rid of that. But if it was an exponent of 2 or 3 or something like that, then we could apply that exponent rule like we did right here. Okay, any questions? Okay, good news today. What do we have? 8 examples to go through? So go, take a look at this one. Multiplying these together. So Lizzie, what do we do with the exponents? We add them, very good. We get a to the 8th. This base, which is made up of 2 factors, is raised to the 4th. So Colson, what do you think we do here?
You multiply the exponents. Maybe 2x to the 4th.
Okay, so 2 Both of them get their chance with that exponent. So we're going to have 2 to the 4th and x to the 4th. Is 2 to the 4th a small enough number we ought to go ahead and figure out what number it is? Hannah, what's 2 to the 4th? 16. Okay. Try the next one. Write your answer down, check with the neighbor. So example 1C, get your answer, check with the neighbor. So I should hear some, hey, what'd you get? Oh, good, that's what I got. Oh, crap, that's not what I got. Check with somebody, I should hear some talking.
I got negative C.
I'm sorry, I'm brain dead.
Okay, listen carefully. Thank you for talking. I like it. I hear some really good things. Is there a negative in the exponent? Is there a negative in the exponent? Nope. There's no reciprocal here. We're going to apply this equally to both of them. So we're going to get a c to the 3rd, and I'm going to have a negative 2 raised to the 3rd. And if I wrote that the right way, it should look like this. So I end up with negative 8c to the 3rd. Raise your hand if you got that right. Okay, can somebody raise their hand and tell us why it's negative? Why is it not positive? Why is it negative? Why is it not positive? Sai?
Because when you multiply a negative twice, it's positive, but when you multiply it again, it goes back.
Very good. Or to say that another way, 1 negative is negative. 2 negatives are positive when we're multiplying or dividing, remember. Okay? An odd number is negative, an even number is going to be positive. Okay? Perfect. Let's take a look at this one. So we're on example D. Take a look for a second. It might be helpful to actually write a negative 1 there. Is there anything to cancel with on the bottom? Any fraction simplification we can do? Not with the coefficients. So this is going to be a negative on the top. Caleb, how many y's are on the top?
5.
Wilson, how many y's are on the bottom?
2.
2. So Luke, specific question. How many y's cancel?
2.
2 of them. These 2 will cancel with 2 of those. So Colson, how many are left?
3.
3. And are they on the top or the bottom? Top. So y to the 3rd on the top. We'll do it again with the z's. 7 z's on the top, 5 z's on the bottom. These 5 are going to cancel with 5 of those. That's going to leave 2 of them. And there were more on the top than there were on the bottom, so I end up with z squared on the top. Do I need this? Do I need to put it over 1? Not when it's over 1. But if that stuff was in the denominator, you better believe I better have that. So it's negative y cubed z to the 2nd. Everybody okay with that? Okay, now pause for a second. Put your pencil down. Go ahead and put them down. Okay. I find that one of the biggest problems with a class like this, among all the other benefits, is that sometimes people don't want to ask questions. So realize that if you ask a question, you might be representing a question that somebody else has. So a really smart guy that I knew, he had this cool way. He was like in his 40s. He would attend these conferences and he would say stuff like this. He'd raise his hand and say, if I'm the only one that has this question, we can deal with it after. But, and then he would pose this question in front of hundreds, if not thousands of people in an auditorium. And then a bunch of people would say, yeah, I've got that question too. So if you've got a question, please make sure you ask. So we're 4 problems into this. We're halfway done. Does anybody have any questions? What does that mean for me as a math teacher? How do I interpret your silence? How do I interpret your answer of,
You're doing a good job.
oh, I'm doing a good job. Thank you very much. I don't usually think of me. I think of you. What I think of is these guys have got it figured out. Nobody has any questions. This is easy for them. Okay. And if that's the case, that's the message you're sending. If it's not the case, you want to be sending a different message. So make sure you ask. All good? Okay. Let's take a look. I see a problem right here. We normally don't write like negative exponents. So this is going to be 7x to the 3rd. I don't like that. I'm going to move it into the denominator. It means reciprocal. And if you've been in one of my classes before, you've probably heard me, or if you've listened to a video, you've probably heard me. If there's a fraction in the problem, you might as well think of everything as a fraction. I'm going to put that over 1. Clearly, the 4, the x, the y to the third, they're in the numerator. So, can I cross-cancel anything? Can I cancel these y's with some of those y's? Yep. 3 y's on the top, cancel with 3 y's on the bottom. That means there are 2 left. And Luke, where are they left?
On the bottom.
They're left on the bottom. So I end up with a y squared on the bottom. I've got a 7 and a 4, and those are both on the top. And this is all multiplication and division. So I can multiply those together. I get 7 times 4. That's easy. I get a 28. Then I've got an x to the third over here, and I've got an x to the, technically, to the first. So how many x's altogether?
4.
4. All good there? Little bit of a challenging question here. There's a couple issues with this. Okay, here's what I'd do. And I'd call it good. Okay. What does the negative mean? Reciprocal. So that means I take the y from the bottom and I put it on the top. Am I correct about that?
Yes.
Was there anything wrong with the x on the top?
No.
No. So it's still an x to the first on the top, and now this is in the y to the first on the top. Everybody good with that? What does negative mean?
Reciprocal.
Reciprocal. So I'm going to take this expression, I'm going to flip it on the bottom, I'm going to leave the parentheses and everything, and the only thing that changes is that. Now it's a positive exponent. We like positive exponents. Now I'm going to apply this exponent to each part of that. So I'm going to apply the 2 to each one of these. Technically, they both have 1s, power to a power. I multiply those. So 1 times 2 is an x squared, and then 1 times 2 is a y squared. Everybody good there?
Yes.
Is there another way to do it?
Yes.
Does anybody want to see another way or suggest another way? Yeah.
Could you first do the exponent outside of the parentheses first, and then?
Do you want to apply it inside?
Yeah.
Okay, so he's suggesting we do this. So this would be an x to the negative 2. This would be a y to the negative 1 to the negative 2. So this would just be a y squared, wouldn't it? What part of this don't we like?
The negative.
We don't like negative exponents. It's not that they're bad. We normally just don't write an answer like that. So let's take this. The y squared is fine. It has a positive exponent. Let's move this into the denominator. And let's do it like that. Is that okay? It's kind of one less step. I kind of like it. Are those the only 2 ways to do it? No, you could probably find a couple other ways. Okay. All right. Everybody good? Okay. At least you've got a couple tools for working with that. Okay. And then let's take a look at these guys. And I'm hoping this is not too bad after our discussion. Megan, do you think there's more than one way to do this?
Probably.
Yeah, probably. Okay. Here's how I do it. Numbers, take care of those immediately. 30 over 60, I'm going to put a 2, it's on the bottom. I'm going to wait and see if I need to put a 1 on the top. I don't like the negative exponent, I'm going to move the a squared to the bottom. I don't like the negative exponent, I'm going to move to the 8 to the 6th on the top. I don't like the negative exponent, I'm going to put the b to the 6th on the bottom, and I don't like that negative exponent, I'm going to put b to the 8th on the top. Everybody good there? Okay. In one step, I've simplified the coefficients, I've simplified the number part of it, and I've got something that makes sense to me mentally. I've got 6 A's on the top. I've got 2 A's on the bottom. I'm going to cancel these. I'm going to end up with 4. I've got 8 B's on the top. I've got 6 B's on the bottom. I'm going to cancel these, and I've got 2. So that means I've got A to the 4th on the top, B to the 2nd on the top, and the only thing left on the bottom is a 2. So I get that answer. Raise your hand if you got that. Okay, keep your hand up if you did it exactly the same way as I did. Interesting, only about half of you, not too bad. Do you have any questions? Great, let's try this. Raise your hand if you got that wrong. Good, thank you for being honest. Take a look around. That's about, okay, now we're at about almost a quarter of you. Okay, so thank you for being honest. Mistakes are not bad as long as we learn from them. So if you made a mistake, did you see where it was? Did you see where the flaw in your thinking was? I would rather have you do 100 problems and make 50 mistakes than do 100 problems and get every single one of them right. Because if you take those 50 mistakes and learn from all of them, you've grown a lot more than somebody that just got them right the first time. Okay? So we're going to slide over and take a look at that one. I'm going to give you a second to do that. All right, more than a second. About 30 more seconds. Okay, go ahead and stop. Look up here. I'll give you about 10 seconds to finish. Everybody look up here. My normal cue for that is listen up, and then I'm looking for everybody sitting quietly and looking at me, which we're almost there now. Okay. Told you before, this stuff on the calendar, anything in blue, you're the third different class I teach of the day, so the last one on the list is blue. That's what you guys are doing. Today is Tuesday the 23rd. We're doing 1.0 exponent review. These are the notes. I always put those at the front of a unit, and this is the worksheet that I just handed out. Okay, you'll get that in just a second. I'll have the people hand it back. It's sitting at the front of the row. So we've got a couple people missing today. If you're ever gone, you can find that stuff right there when you come back the next day. And Miss Doty and I are trying to keep the website updated. So if you happen to be home, you can print stuff and then watch a video and things like that. It will take us till later in the day to post a video. This is the first one that we're recording and everything. Okay. All right. Any questions? Okay. Go ahead and pass those papers back. And I would like somebody to volunteer to say, what do you think we ought to do first here? What works in your brain? What do you think, Samara?
Well, I simplified in the parentheses first.
Okay, so Samara simplified in parentheses. That is what I would do, okay? Because the minute I can make this stuff inside the parentheses, that also fits with the order of operations. If I can make that look nice, it just relieves things in my brain and I go, okay, I think I can deal with this. So we're going to ignore the outside for just a second and we're going to simplify. I'm going to take an a to the third. I'm going to move the negative a to the top, negative a to the 1, okay? B to the 4th, B to the 3rd, and I'm going to take that c squared and I'm going to put it on the bottom. So there was already a c squared there and there's another c squared. Now, if I want to write it like that, I can. And then there's one other thing that might be helpful. This is the idea that I do everything right here. I just did one step. If you can put these together and write a to the fourth in one step, could you do that? That'd be totally okay. So I'm going to write a to the fourth. Could I, since these were both positive exponents, could I just say, oh, that just means there's a b to the first left on the top. Would that be okay? And that means there's c to the fourth on the bottom. Everybody all right with that? If you can go from here directly to there without showing that step in between, thinking through the step in between, that's great. What do you want to do next? Do you want to flip it, or do you want to apply that to everything in there? What I would normally do is flip it. So I do c to the fourth, a to the fourth, b, and then I get to raise that to the fourth. The negative has taken care of the reciprocal part, and now all I need to do is apply this to each one of these. So I apply this here, I apply this here, and I apply that there. So that's going to give me, correct me if I'm wrong, c to the 16th, a to the 16th, b to the 4th. Okay, did I get that right? Raise your hand if you got it right. Okay, excellent. If you made a mistake, that's not the end of the world. You learned something from this. We've got a bunch of practice. Everybody's got the paper in front of them. That is practice. It's exactly what it's called. Okay, it's not the end of the world if you miss something. Most of you play piano, do dance, do sports or something like that. The first time you practice something, you're not expected to get it all perfect. Okay, our goal is when we take a test on this, and more importantly, when we need to use it later this year and next year and a couple of years from now, that we've got good solid exponent skills. Do you have any questions? Okay, how many problems are on there? 35. A self-assessment counts too, so we've got 36 problems altogether. Should we do them all?
Let's do multiples of 1.
Really?
No.
Never heard that before. Let's see. Get rid of multiples of 5. Okay.
Thank you, Mr. Laws.
Okay, let's try that again. Get rid of multiples of 5.
Thank you.
Mr. Laws.
Oh, that's way better. Yeah.
If we do them, will they count as extra credit?
We could have it knock out something that you didn't do. And here's the other thing. So thank you for raising this, Samara. Just because we crossed off multiples of 5, does that mean those are bad problems? No. Okay, I'm just being nice on the first day. I'm trying to get on your good side right now, right? Okay. If you see something on a multiple of 5, you're like, at least look at them and you're like, oh, I know how to do that. Great, leave it off. If it's like, ooh, I'm not quite sure, maybe try it and make sure you know how to do it. Okay. It's about doing enough practice that you know how this works, and you can depend on this skill in the future. Okay. All right. All good. All right. Perfect. Get going.